in a second, so you'll get a message. There we go. So welcome to PHPMiNDS.
Lovely, thank you. It's so great to be here again. And I have such a soft spot for Nottingham because that's where I first lived when I came from Mexico many years ago. I was 15. So now, you know, at least 6 years ago or so, give or take a decade or 5 or 20, who knows. But it's great to be here, and it's really good to be exploring this with you because I'm sure everyone here has dealt with technical debt. So this is the approach that I've taken, and sort of the model and the toolkit that I've used, and it'll be interesting to see how it resonates with yourselves and, you know, what I'm missing or what's useful. So my name is Ismael Velasco. I am a Mexican cosmopolite living in Suffolk in the UK. I am a PHP developer and a professional opera singer. Only one is true, and I'm really hoping by the end of this, you think it's a PHP developer. And you can find me on Twitter in Dev on a Journey. I find Twitter a fantastic space as long as the only people you follow are developers. Then it's really, you know, not toxic, supportive, interesting, etc. You venture a little bit to one side or the other, and it gets scary. But this is the account I use for those conversations, and I have found them very enriching, not least in bringing me to PHPMiNDS. So thank you so much for that invitation. So what is technical debt? Many definitions. This is by Justin Stone, I think, from Liberty Mutual, who pioneered serverless first approaches in really exciting ways, worth hearing sort of those podcasts. But he defined technical debt as the result of the design or implementation decisions you make and how those decisions age over time if they aren't incrementally adjusted or improved. This seems the most accurate one because some of them emphasize technical debt as a result of prioritizing quick releases or budget, but you can also have a state-of-the-art application in 2010 that hasn't been modernized, and now what was state-of-the-art is no longer. So it is whatever implementation decisions you make, if they all age in one way or another, and if they aren't incrementally adjusted or improved, then the cost of fixing them increases. So this is a model that I've got in my head. Technical debt is not all bad. So you can be in technical solvency, you can have low interest technical debt, high interest technical debt, and a technical debt default. So solvency is where we all love to be. Your infrastructure is elastic, scalable, low maintenance, and cost effective. Your architecture has loose coupling and high cohesion. It is composable and adaptable, documented, secure, and environmentally sustainable. That's all your code bases, isn't it? Processes and teams aligned with values are agile, thriving, commercially integrated, efficient, effective, and enjoyable. And our code quality is uses state-of-the-art tools, and we have outstanding learning culture and inclusiveness that attracts and retains talent. So that's really the blue sky thinking. That's where you'd like to be. It's an ideal type, as the sociologists call it. It's something that allows us to know sort of roughly where we're headed, but obviously no one is always there. And it's not necessarily the best place to be. Technical debt, like real debt, can actually be incredibly useful. So we make technical trade-offs often for higher business value. When it's low interest technical debt, our technical debt enables speed to market, rapid adaptation, and prioritization. And the problems our technical debt entails are in the future. And we have a timeline for paying it off before the problems emerge. So there's one incubator in Wales, for example, that brings together students and facilitates startups. And after a few iterations over a few years, they've now priced in the fact that any successful team will eventually need a complete head-to-toe rebuild of the application that allowed them to gain traction. And now that's part of their business model. So they incur the technical debt. The product is good enough for proof of concept, good enough to gain traction, good enough to prove value. But of course, the moment you get traction, the gremlins start to eat you. And they've already planned whether to bring an external expert, because these are sort of mostly quite new people, or they themselves, whatever approach it is. But the point is that technical debt is at low interest can be of great value. There are bits of your application that need maintenance, but this killer new feature is going to help you take off. So you know that this will cause you pain later, but it's not right now, and the value that accrues is great. If you don't pay it off in time, eventually, like in real debt, your low interest debt begins to cause penalties and becomes high interest debt. High interest technical debt is technical debt that generates ongoing problems and painful constraints. The problems are not in the future, they're in the present. They're biting you now. And they move from a tactical to a strategic risk. So where before you go, okay, this may affect how we process this data or how we tackle this particular ticket, the strategic risk is, okay, if we carry on this way, we will have trouble with our business proposition or our key value or our safety or reputation. So the financial cost of the technical debt in a high interest scenario accrues around the business. So your time to markets gets lower, you might become competitively disadvantaged against newer or better, more stable apps, and your engineer time is spent more on maintenance than on added value. Hiring and retention become challenging, requiring salary inflation to compensate for the lack of an attractive stack and generating quite a lot of churn. So this is a place where you're not happy. This is painful. It's a bit too late. You need to change it, but it's hard to change it because you still have to maintain the app and develop new features. And this is where I think a lot of us get to as a function of success sometimes. So, we went into monoliths, and then our monoliths grew and the internet grew and speeds grew and the cloud computing came in, and suddenly those architectures were struggling, and we had a huge amount of technical debt that was causing exactly these problems, whilst simultaneously thinking of decoupling and moving into a microservice architecture. And now that's been long enough that quite a few people did that and then found themselves with the worst of both worlds, with low cohesion and high coupling in their sort of microservices. So now there's a whole generation of businesses and application sort of trying to resolve that debt of those choices. And here you'll move either back toward the green or toward the red. You're not going to stay there. There is for each of these periods, there is a kind of time window. And this, I think, quite important when it comes to articulating the importance, significance, priority of technical debt to the business. That this is not where you stay statically. You are either moving toward the right or toward the left. You don't stay still. And the last bit is, if you haven't dealt with it, if you haven't had the backing from the team, or you haven't had the resources or the know-how, you might reach technical debt default. So this is technical debt that creates critical vulnerabilities and reputational risks. You are one bot away from an SQL injection, or sort of one critical failure or incident from losing your place. your language or your core dependencies reach end of life and become exploitable. You're still on PHP 5 when 7.4 is reaching end of life. And then you can just Google it and find exactly all the critical exploits that you can use. And sometimes it's even, I think it's 7.4.1, which has a terrible exploit that 0.2 resolves, for example. So it can even be just tiny tweaks, but there you are. Your architecture or infrastructure is unable to cope with new demands, and service disruptions are common. You hemorrhage staff in search of a better developer experience and face critical difficulties in recruiting. Crisis mode can strain your team cohesion, their mental health, their cognitive load, and new features just grind to the halt as clients begin to leave. So, and this is a scenario where you can, I think the transition from yellow to red is probably easier than from yellow to green, probably significantly easier and much more observable. You know what you're looking at when you're in green to yellow. But once you're in yellow to red, a lot of the stuff is mysterious. There is a lot of magic. So a lot of technical debt is often around observability and quality assurance. So once you have this kind of framework, you are able to position your application and your code along the spectrum. So you might have, a new website. You've branched out to the EU, for example, from a UK-based business. And because it's brand new, that's really near technical solvency with its dependencies on your old code being a low interest technical debt. It's allowed you to get into the market, a new market grow, etc. And then you might have, some feature bloat of if you're in a legacy application or under resourcing, if you've lost staff or whatever, or you've grown. Actually, that could be the other way around. You've succeeded, you've grown, but you haven't yet reflected that in your engineers. You might have inefficiencies that you priced in because they help you get clients or roll out new features. Your tech stack might be old or poorly implemented. You might not be using a framework or using a really old one. Those are there. And then you might have symptoms of more high interest technical debt. So you have frequent defects per month. There's something called escape velocity. So how much of your commits or merges end up coming back or generating new bugs, and what is the rate at which this is happening in each sprint or each month. If you're having frequent new defects per month or returning defects per month and they're trending upward, you're in a high interest situation now, because that's just going to keep accruing. And you might have barriers to commercial growth now, because there are things that your competitors can do that you cannot do. So for instance, you may not be able to integrate easily with a third-party system that is now the benchmark, but your architecture doesn't play well with them, so you have to make do. You may have barriers to your data management and storage, whether it's around speed or around data discovery or around GDPR. You might have barriers to ops because your processes become stale as they struggle with the limitations. So, it's harder to prioritize tickets, to scope them. If your technical debt is high, if you can't predict how many defects you're going to create, etc. And one of the fifth pillars of AWS is our good architecture, which are replicated with different language in other places, is sustainability. Technical debt goes very closely hand in hand with heightened emissions and carbon footprints, as well as just cost, both in terms of maintenance and infrastructure, etc. So often addressing technical debt can be part of your journey toward net zero or sustainability, as well as sort of cost savings. And then once, some parts of your application might be in a state of technical default or borderline default. You might have dependencies that are now, super hackable and crawled by bots, or you may have scalability ceilings that mean that you know that you can't grow more because life is going to come crashing down and you can be a victim of your own success. You are having serious service interruptions. And one of the interesting examples of this trajectory was in one of the companies that I sort of collaborated with. I was looking at a history of their incident reports and over a period of like 10 years. And I found this fantastic little quote that I think sort of just sums it up. They had a severe enough incident that they recorded it, but it wasn't big enough that it had particular business impact. And at the end of it, they had a comment that said, this incident would probably have been avoided had we invested a bit more on logic separation. And then you see the incident reports over the years, and they get more and more serious. It begins in, a part of the service, then it goes into an entire layer, and then sort of an entire business function literally shuts down. And I was just thinking as I was reading that you could have penned that quote at the bottom of each escalating critical incident. This could have been avoided had we invested in better app separation. That tight coupling meant that the compounding technical debt also compounded the cascading effects of the interest, as it were. So having this framework, sort of how do you actually place, how do you evaluate your code, your application in this spectrum in order to prioritize or to identify roadmaps, etc. So there's quite a few tools, but before that, one has to take account of sort of the process and the politics of it. And I'm sure that this and the next slide are so familiar to you and to whatever discussions you've ever had in team and with business around should we or shouldn't we. There is the imperative of velocity of new features and in product improvements. And then there is the slowdown of fixing technical debt. All the time that you devote to technical debt is time that you do not devote to adding new value in that sense. So there is a loss of velocity, and in not just in your engineers, but in your business potentially. And so it can be quite a hard sell to say let's focus on technical debt. And one of the most important, I think, challenges for engineers dealing with technical debt, particularly in sort of strategic positions or leadership positions, is how to speak business, as it were, how to translate the technical pain that we suffer into the commercial and operational value judgment that will allow you to determine sort of how to invest and get organizational buy-in. And I think this graph is helpful in that sense. So you know that investing in technical debt will eventually boost your velocity until you break even to where you were, but then you should dramatically accelerate is the theory. Now, you can also invert this, right? You can see how the growth of technical debt diminishes your original velocity over time or your original benefit. So it might be that your velocity, you're still sort of coming out with issues at pace, but your issues suddenly start becoming more and more focused on bugs and maintenance and less on features. So this kind of graph or sort of visualization, I suppose, can help make those arguments or embed the framework I described earlier into a time benefit analysis. And it's quite hard to have that big picture to make these assessments when you're in the trenches. And this is where you are once you're in high interest. Once you're in a company or working with an app that has, you know, business dependencies, people are developing new features, asking fixes, etc. And you get to the yellow zone, this will happen again and again. I don't understand why it takes so long to add a new window. And that's what it looks like, right? That's what our job looks like. And once it's gotten to that state, it's really hard to say, you know, give us 5 years to rebuild a house and then we'll, you know, start doing the windows that you asked for. So this is a tricky bit. And at the same time, you have that primary obstacle, which is can't stop too busy, that the pressure to maintain business value with and keep moving forward with square wheels. And really all new entrants, your competitors, will likely begin. They might be much smaller and have less momentum than you, but they probably have better wheels. So judging when you are in the green zone and the blue zone, and when you are in the yellow zone or the red zone, can really help you identify the cost to the business and what you really should prioritize and how. So how do you actually operationalize a framework like this one? This is another sort of, this is the complementary trend to the time benefit one. So this is, you know, how fixing benefit relates to that. And this is how unaddressed debt affects the engineering process for the business. So in that second, third, maybe fourth bar, you're probably in the green zone. There is a little bit there. Once you start getting to the fifth and sixth one, you are in the danger zone. If you don't course correct, you will start tipping into the yellow zone, into the high interest zone, where your red is a bit bigger than your green. And that doesn't necessarily mean that you are dealing with bugs more than with new features, but it does mean that your entire development process is decided increasingly on the basis of the limitations of your system than its possibilities, until you get to default and something terrible happens at some point. So mapping both as an entire business application, but also the functionality, whether you have a modular monolith or just functional business functions that are, you know, in that situation. And again, one of the things that helps is things like wordly mapping or domain-driven design, which are two separate talks. But, you know, domain-driven design is much better known in Britain, I think, than wordly mapping, but they're quite complementary. And they are essentially a way of embedding engineering into business and user logic. And what that would mean is that here, this, if I'm breaking out my application or my product into this framework as an engineer, it's likely to look like this one. I'm focusing on the functional elements. But if I had a domain-driven design where the areas of my code map onto business functions that are intelligible across the business, then it will be incredibly powerful to know that payments are in the yellow to red and subscriptions are in green and sort of data protection is in yellow, etc. And that would not be a high-level thing. It would actually link to the specific areas of your code base. So there's a lot of room for those kinds of translations. So what tooling is there? Well, there's been a lot of academic research that has gone into empirically assessing how to measure, how to predict, how to judge technical debt, and likewise a good amount of sort of case studies and tech experience that has been sort of aggregated into good practices and learning. So what you're seeing here is one of the graphs that come from a tool called PHPMetrics. I don't know if you've heard of it. There are equivalents in other languages. But what PHPMetrics does is it takes basically all of the established academic algorithms for calculating technical debt and runs them against your code and then gives you a diagnosis. So in this case, I believe the graph is around code complexity and maintainability. So by various metrics. So the red is less maintainable and the size is more complex. So they're not always the same. So one might be, for example, very tightly coupled, so very vulnerable to changes, but not be particularly complex, just very risky. Or one could be not particularly tightly coupled, but its logic is spaghetti and a nightmare. So interesting, I saw, and I couldn't find it very recently, but there is out there a map like this one for Wikipedia, and it looks terrible. And yet they're doing pretty well as in terms of the kind of traffic they manage, etc. So their approach to technical debt, I think, definitely deserves study because they've got masses of it, but they're somehow making it work. And I'm sort of, I think in a week or two, I'm giving a talk on what I've learned about best practices in modernizing monoliths. And that's a really good sort of outlier insofar as they've kind of stuck to their old monolith and just made it work. But PHPMetrics then is one of the best tools that you could use to begin to have a sense. Let me see if I can show you. So this is phpmetrics.org. So if we look at the kind of report you get, you can obviously decide which bits you measure. So this is just telling you the violations it found in the code according to a set of algorithms. I'll show you some of those. In this case, it's too complex method code and probably bugged. I think the creators are French, so the English isn't entirely smooth, but it's very powerful. Now, there are other violations it can report. So there it's too dependent. It highlights God classes, for example. It highlights a huge amount of detail and it links them to specific pieces of code. This class looks really complex. The maximum cyclomatic complexity of class methods is 10. Maybe you should delegate some code to other objects or split complex method, etc. So these are some of the metrics applied. So these are all well-established research algorithms for measuring code complexity. So these are logical lines of code with and without comments. And the idea is that code should be as much as possible self-documenting. So if you've got lots and lots of comments, then your your code is likely to be more complex to understand, to take more cognitive effort if you've got to actually read the comment in order to understand what's going on. Volume has been found to be a predictor of technical debt. The proportion of intelligent content, the weight that comments play in the code, and you can see that it is sort of broken down by class. Then you have a different measure. People have come with a number of measures, I won't go into the detail of what is cyclomatic complexity and system complexity, data complexity, structural complexity. One that is not here that I think SonarLint uses, that's quite recent and increasingly popular, is cognitive complexity. So there are some algorithms to estimate cognitive complexity. In this instance, it's worth mentioning that a lot of recent research has identified developer cognitive load as the key constraint in developer productivity and quality. So it's not about how many developers you've got working on a problem, it's about how much cognitive load they have. So if you have someone who takes ownership for an area of code, they'll have less cognitive load than assigning that ticket to someone who hasn't worked with it, for example. So these measures of complexity are, in a sense, also measures of cognitive load. So somewhere that has a lot of system complexity is quite predictive of bugs and defects. And there are, again, a number of algorithms, Halstead, Kahn, there's a few more. And generally speaking, there's been a few experiments where they've applied these algorithms to a large piece of code on GitHub, and then sort of compared that to sort of what that model would predict in terms of bugs and defects. And usually the prediction rates are in the 70 to 80%, sometimes 60%, but the point is that they are predictive. So if it says, you know, probably buggy in the violations using the sort of the bug and defects ratings like that, it's saying this one is probably buggy. And if you run across your app, you'll see lots of it. I think probably a better way of describing it is bug prone. So developers working in that area of code are more likely to inadvertently introduce a defect or a bug without meaning to. So those kinds of ratings are not, you know, futuristic predictions. It does not mean that because it has a high rate, it is going to be a bug. But when you aggregate it, it's pretty likely that if you're anything like the norm, your team will generate bugs in some of the high sort of scoring code. They also bring object-oriented metrics. So these are again around class complexity in particular. And also there's sort of two elements. One is sort of, again, lines of code in a class have been good predictors. The volume of the class, a really big class, is likely to be a risky class, one with technical debt. Again, sort of one that has a lot of methods or whose methods are very complex or which has a lot of logic density. But it's also about relationships. So, this one does this, I think, more around dependencies as well. It also does a dependency analysis. But it's quite powerful as well. This is where you get God classes, for example. So they measure coupling in two ways. One is afferent coupling, which is the number of classes affected by a given class. So a God class would have very high afferent coupling. It means that one class affects lots and lots of classes, which means that if you are refactoring that class or developing new features in that class, the risk of unintended side effects in other classes is obviously much higher. And effort coupling is the opposite, is the number of classes from which a class receives effect. So a class that depends on lots of other classes is again more unstable because it's harder to predict how future inputs might affect it. So these are all good maps in terms of sort of mapping the areas of your code that are in blue, green, yellow, or red, and how that affects potentially your business domains. And to do it at the, at the class level, so that you're able to prioritize your refactoring, both in terms of the level of technical debt and the level of impact and risk. There's another dimension of technical debt, which is security. I find SNCC really powerful and helpful. It does involve, I think you can, if you pay for it, maybe have it in premise, but mostly you do have to send your code to the cloud, so that is not appropriate for every business or every model, but there are others out there, right? So security scanners are nowhere near the same as pen testing. And a lot of pen testing businesses and applications are just doing static analysis and security scans. So if you're ever going to sort of pay someone to sort of do security testing for you outside, make sure that they go way beyond scanning. And also make sure that you introduce scanning into your continuous integration pipeline. If you don't have one, then that you do it regularly. So this is really powerful because it scans not just your code, but it particularly focuses around configuration, open source dependencies, and container vulnerabilities. And so it matches all the databases of known vulnerabilities and bugs to your codes. You might be using a PHP method that has been cracked. You might be using a hashing algorithm that is now trivial to break. You might have something exposed, or you might be missing security headers that expose you to cross-request scripting attacks, etc. And you have, again, measures of vulnerability. So the critical ones here are by already, whichever critical ones you have, put you on the borderline of red for that area of code, because you are genuinely crossing your fingers that either a determined or opportunistic hacker or a sort of powerful crawler goes through your app and just finds the gaping hole that you didn't fix. And very often, massive vulnerabilities are 5 minutes to fix. Obviously, if you've got hugely afferent or efferent classes, then your confidence that that little change that would fix it won't affect other things diminishes. But yes, including mainstreaming security thinking, SecOps as it's fashionable to call it now, but mainstreaming it to all stages of your process so that you're able to flag these things is really important, and static analysis is your friend. And you'll often find there's huge overlap, that the areas of code that have sort of demonstrated the most risk are also the areas of code that are often most insecure. But often it's literally upgrading from point 1 to point 2, and a vector vulnerability is being closed or adding a header. So yeah, security tooling. Other static analysis tools are very helpful for Debson, or Lint is a really good one. There is also an interesting algorithm called ZZZ. I don't even know how you pronounce it. SZZ, and it was introduced already in 2005 and been improved and sort of been reproduced as valid. And what it does is it does quite a sophisticated analysis of all your code commits against Sonar lint bug reports. And it allows you to quantify in quite a sophisticated way to what extent the code that you're producing is generating technical debt, is predictive of future defects, and what your rates are of the term suddenly escaped me for sort of regressions that you create. So this is quite a powerful thing as well that takes a bit more work to wire in, because it's not really being developed by developers, but by academics and data scientists. It is used to power the technical debt data set, which is a kind of source code that's been kept kind of constant, open source, to which this algorithm has been applied and is continuously applied. And it's one that, you know, others can use and write papers on the back of. But it is a kind of thing that I think should be a project to incorporate into our continuous integration and sort of issue management systems, which brings me to the to issue management systems, whether you use Jira or you use GitHub or GitLab or whatever it is that you use. Bitbucket, your issue trackers can be quite a powerful way to understand technical debt as process. So for that, you can aggregate and quantify certain vectors. So you can quantify, for example, how many defects per month you are creating. So you can look through and sort of you can do this. I'm not sure whether you can do it in Jira Analytics. You can certainly wire it to Tableau and do it there. But you can basically create dashboards if you wire it correctly, that will allow you to see, for example, the average time to resolution of support tickets that have commits that say fix, commits that say bug, however it is that you're able to tag. It's a kind of more manual approach to the SZZ approach, but it's one that can be done quite quickly and powerfully. You're able to identify sort of how many of your tickets over a period of time are related to bugs, how many tickets that have been closed have been reopened or sort of referred, what tickets have had the longest discussion and comment threads, and these things can be incredibly powerful when it comes to carrying a cost analysis. So if you have visibility into the either your developer salaries, if you're in a very enlightened organization, or your staff, aggregated staff budget, if you're in a less sort of enlightened organization, or market benchmarks, if you just don't know, you can convert the percentage of time spent on all those maintenance and bug tickets in terms of hours, estimate. It doesn't even have to be precise, but rough average engineer hours, right? And that includes, the junior and the senior. So it might be median, however it makes sense to you to do it. But you're able to come up with a very specific financial sort of a costing of the most overt layer of financial debt. So this is not opportunity costs. This is not sort of innovation constraints. This is not time to market. This is not competitive disadvantage and market share. You can do analysis on all of those things also. But this is literally the bread and butter of, we've got this much team. This is how much we spend on technical debt at the moment because we're not maintaining it. Or in this area of code or this area of business functionality is costing us this much away from product improvement or feature development. And what's even more powerful when it comes to making the persuasion, the influence case, or yourself judging how important or not it is to compare what figure you come up with to other headline brackets in the business financials. So, you might find that one arm of the business generates X amount of profit, and that you spend the same amount of profit as that entire division on technical debt alone, without any particular plan to do it because you're being pushed with that, with the bicycle. I don't have time to fix it. So being able to translate your technical pain into strategic and financial and operational costs of time, of impact. You can also then trace, rates. You can trace how that rate of sort of defect, of escape velocity may have grown or diminished. And you can see how different processes have affected it. Maybe you brought in a new manager or a Scrum Master, or you've sort of left Scrum or introduced Scrum, or whatever it is you're doing. You can see whether it's having those effects. You can also judge whether it's more cost effective to just move to a platform as a service for 3/4 of what you currently do in your code base, or whether, actually hiring a team to rebuild your app whilst your existing team maintains it is cheaper over a period of, 5 years than keeping up with these kinds of trends. So this creates a fantastic platform to bring in other parts of the business, to get other business functions to help you cost it, to go, to HR and say, how does this compare, or how would you estimate, the salary value of these many hours for our team, to go to, the finance director, manager, or department, depending on the scale, and saying, could you help us quantify the sort of the impact on your forecasts of these kinds of metrics, etc. And at the end of it, the chances are that you'll be able to come up with strategies that are realistic, and realistic not just in terms of what can be done with business as usual, but how long your window of business as usual is. How long will you stay in high interest before you hit default? And when you hit the red zone, how costly are the risks for the business, so that the business can then decide, the risks are so high in this scenario in 2 years' time, that unless we seriously, stop new features, somehow maintain it and invest, or borrow money to, rebuild it with a new business, or rethink our business model, our life is on the line. Or vice versa, we're in green for quite a while. So at what point in these areas of code will we begin to sort of go back? Always bearing in mind that each jump from blue to green, from green to yellow, from yellow to red takes twice as much, or exponentially, not twice, exponentially more effort to revert than the earlier you kind of catch it. So being able to map your code along such a framework, and even if you're too late in some areas and you're in red in one zone, to not be blind in your green and yellows, but to actually know, hey, this is great, we're in green here. How are we going to, measure where we're at, or what's critical here that is in yellow, etc. So I guess that's the last bit of this approach is that you take tech debt really seriously, and we all do, but often we do from the point of view of that cyclist. When tech pain gets painful, we're moving on square wheels and somebody's behind us telling us to hurry, or we're trying to fix a window in a crumbling house, and then we know, but we're driven by pain rather than by data or strategy. And that can also be quite demoralizing and compound the matter. But being able to have a strategic approach, ideally being able to integrate these things so that they reduce your cognitive load rather than add to it. So you're not going through all these 5 tools, analyzing it all, but actually just integrating those tools into your code analysis, coming up with some nice visualizations that crunch the data for you, investing a month on that. And then the last thing that I'll close with is, how do you get out of here, right? If you're in yellow or in red, you probably already, short on all kinds of essentials for whatever reason. You may have just inherited a new team that, or moved into an app with, hugely legacy code, etc. So how do you direct and move and strategize the change? And I'd say that this is an area where the whole business needs to be engaged, and a roadmap that's realistic in both terms of resources, in terms of costs, and not just current costs, but cost trends and hidden costs, but especially in terms of risk, strategic risks. There is a point at which that state happens. And the other risk is that you break things when improving. So I would say the 2 other areas that are prerequisites to moving back toward the left of that framework, if you are in borderline yellow-red territory, is to invest on observability. So get the right logs, not for everything, but embrace failure, break things heuristically, plan for failure, have plans B, and gain, automate as much as possible. So for instance, I don't know if you've heard of model-based testing. It's just a heuristic. It's not a replacement or necessarily an improvement on things like, a full testing suite. But it's a nice start when you're starting from red, which is where, using a number of tools, you map your application from a business and from an end user perspective. And this is a good opportunity to do some Worley mapping or subdomain domain mapping. But however it is, you basically map your functionality in a way that is meaningful to the consumer of your app and understandable across the business. And then that map that you've created automatically generates for you a whole set of test cases. And depending on the nature of your code and framework, potentially even the test code that you can deploy for end-to-end testing. That kind of testing will not necessarily tell you what broke something, but it will tell you what part of the system broke, and you'll be able to break it early. being able to explore things like feature flags so you can test in production safely and break things in production safely. Again, that's an important element. Sort of chaos engineering, ensuring that, again, you embrace failures, you plan for them, you welcome them, you incorporate them systematically into your learning and preparation process. And therefore, suddenly your red can become your friend. If you can create a resilient approach to failure and maximum visibility and observability with maximum automation, then your failures become your tools, your bugs become your diagnostics, and together with the metrics, allow you to map a way back to the nice blue ideal types of the technical solvency and surplus. So with that, I think I can now conclude this presentation. If there's any questions that don't fit here, you can find me on Twitter, in Dev on a Journey, email me. And that last one has nothing to do with this talk. It's to do with a talk on webhooks that I gave and I used as a template. So ignore that, that sort of repository. So, but yeah, please do reach out on Twitter, reach out on Slack, reach out on any channel. So thank you very much. I see there is a chat, but I haven't looked at it. So I'll have a look now.
That's great. Thank you very, very much. So yeah, as I said there, has anybody got any questions they want to throw forward? Feel free to unmute yourself or drop them in chat. We'll ask them on your behalf.
And also just, reactions, does any of these resonate with your real life experience of having dealt with brilliant and terrible code bases, which I'm sure you all have, and with, the business and organizational tensions between, the various imperatives out there? Was it's just trying to code well, kind of thing. So yeah, I'd love to hear how whether the model speaks to you as well, or it's just in my head.
Yeah, I'm happy to comment on that. I certainly think it resonates. I like your use of color and certainly the low interest, high interest. One of the things that I started adopting a little bit, following another talk, was talking about technical risk as well sometimes, because that moved things away from low interest technical debt, because a lot of people will happily live with that technical debt, not fully understanding it, I think, sometimes. And your low interest, high interest really chimed with me there, because it's, yeah, how do I say that this is, like this, but it's going to grow in a language that the kind of non-technical people can grasp onto. That's really kind of important, I think, as well.
And when you have even a vague financial benchmark, even a vague figure, having those discussions of saying, let's just imagine that this figure is right. This is how it compares to, our turnover or our investment in equipment or whatever it is. That I find can be quite a helpful tool.
Absolutely. I've got a kind of question as well, if I may. If anybody else wants to go first, feel free.
I'll ask a question actually, but if you want to go first, PHPMiNDS. I was just sort of, first of all, Ismael, what an amazing presentation. I was cringing slightly as I was reading that, in particular the first slides, and I resonated very much with the right-hand side of those slides, unfortunately. There's an awful lot of pain that we're going through as developers at my company at the moment, and it is a technical debt problem, and you've made me realize how true that statement actually is. So my question for you is, and thinking about how I would form this, but I'll give it a shot. What do you do if you're already in technical debt default? And I'll sort of give a bit more detail about perhaps the situation that I'm in, where we sort of can't keep up with, I'm hoping I won't go into too much detail here. I'll say something that well, anyway, we can't keep up with core framework upgrades. We can't keep up with the demand for new work, and we've got no time to innovate. In fact, let me turn my camera on now, guys. I've just moved house, so sorry for the state of it. So how do you start to solve this problem once you're already in technical default? That's the question.
That's a fantastic question. This sounds like a complete promo. This is exactly the subject of my next talk in NorDev conference. But and I basically looked at what are the patterns that different organizations have followed who have hit this kind of barrier, right? Like any organization that was founded in the 2000s will have reached an architectural bottleneck, and they'll all have monoliths, and they all have addressed it in different ways. So the most sort of fashionable is decomposition into microservices. That's what everyone talks, right? And there are strategies for it. One of them is called strangulation, where you sort of find the lowest risk bit of code and you turn that into a microservice and you learn from it, and then you try again and you carry on doing that until you've got your lovely microservice architecture. The problem with that model is that most of us do not have 300 engineers, and most of us have a product to maintain. And very often you'll get someone going, let's do this, let's go in this direction. But you look at it from the outside and you're going, in this race, I think you're losing. You know, it's like for every new microservice you've given me, I've got now 3 new features that are tightly coupled. So that's one approach, and it can work. And that can sometimes also involve sort of, you know, a decision around language. Do I stay with PHP? Do I move to Go? A lot of people are moving to Go, for example, from PHP, etc. Won't go into much detail. That's one. Another pattern are people like Etsy and even more Wikipedia, which is they've got a bad monolith, they make it better. They stay in the monolith, they don't go all fancy, they are low risk in that sense. Now, if you're Etsy, you're cheating because you've got the creator of PHP on your staff team. So the level of optimizations that they're doing are not necessarily realistic, right? It's like, yeah, we've stayed with our, we've pushed PHP to the very fringes of what it can do. Whereas Wikipedia is a better example because they have this incredible app that's been consumed at such scale. And it is terrible. It's really, really, really cruel. Like if the PHP metrics, they make me feel better, do them on you and then do them on them. And you go, which means that there are ways of living with it, right? So to me, the key principle is if you can move to what someone called a strategic monolith. So a decoupled monolith, you're still in your monolith, but you have more decoupling and high cohesion, right? So you identify your God classes, and then you're not refactoring the entire app. And it really helps to track it to domains and you know, the business side of things, because then you're able to prioritize and refactor accordingly, for example. Then there is, you know, serverless, a whole, as far as I can tell from what I've seen, it is the inevitable future. Is where serverless is now where REST APIs were, you know, 10 years ago or so. And in that sense, a lot of companies have been investing in that. And that has two shapes that I've seen. One shape is how much of your functionality could you entirely farm out? And you'd be surprised. You know, the cloud now is really sophisticated. And the business case for it grows once you make the kind of analysis of technical debt, where you actually take a radical approach and you say, all our authentication will be done incognito. All our processing, all our recommendations, like virtually everything you can move, you move. And so you essentially replicate your app very quickly. The advantage of that is that it also creates a very low risk environment to innovate in a cloud environment, right? You can spin up a server, you can try machine learning, you can, and then undo it, etc. So that's a strategy that sort of Liberty Mutual, for example, went to. They had already broken into microservices, so they had a lead, but that was transformational for them at every level. And the last one is serverless as a service. I feel like both cringy and proud of being able to say that sentence. There are, like, I don't know in what industry you are, but for example, in e-commerce, there is a company called Commerce Tools, and they basically give you microservices as a service. And big companies, complex companies with really difficult, peculiar personal flows, like Lovecraft, which does, you know, personalized crafts and pattern shaping, and Moonpig, where every single card is customized and there is no delay tolerance, because although you've only paid £2, it is your mom's birthday or your anniversary. And there's several of these big companies that have entirely migrated to Commerce Tools. So they, instead of doing their own serverless or their own microservices, they've identified that they can replicate the core of their business functionality with that. And because they're completely composable and incredibly well documented, then it also means that it's genuinely, you know, you can replace this one with yours at any point. You are not tied, you don't have vendor tying in that sense, because you can just use all of Commerce Tools or just a bit of Commerce Tools. I haven't used them, so I can't, you know, I don't have a horse in this race, but I can say that the kinds of companies that I saw that were having similar pain points, some of them resolved them. And for me, that one is very attractive for someone in the red, because if there's any way that you can buy yourself time, right? Not just to recreate, but even to upskill. Say you decide Go is the way to go, and your team doesn't really know Go, but you are gonna, you know, you find that there are barriers with, you know, async PHP, whether you're using Swool or Roadrunner, etc. You decide, no, I want to go, but we don't know what we're doing. Great if we can move to Commerce Tools or something like it for a year, whilst we build our unique magical thing that plays with Commerce Tools, etc. And we no longer have to worry about the business crashing. Those are the broad strategies that I've seen. Obviously, industry, team, management, all of that will shape your choice. But I would say in the red, anything you can replace wholesale is your friend, compared to anything that you replace piecemeal or refactor, because the asymmetry, unless you can invest, you know, and that's the other one that I mentioned, is hire an outside team to create, you know, go startup-y again, right? Create a proof of concept that replicates everything your app does, but is scalable. Hire someone else to do it if need be, and then do A/B testing, you know, begin to migrate, have fantastic observability, and really good failure strategies. And that's another way of doing it, right? You convince the business to reboot, and you maintain, your team can even stay, if there's enough money, your team can stay doing what they've always been doing, waiting for their new home. They can all have a massive input on the design of the new sort of direction, but potentially you have completely fresh devs who, are all up to date with where you want to go, and do it with you in a way that is fully owned by the end, as opposed to, now what do we do with this machine that someone else built? But that would be another strategy, I think. It's ultimately, I don't think you can get out of the red without reinvestment. That's the bottom line, and that's why I spend so much time on the cost analysis and the metrics, because I think once you're in the red, it's going to cost you. But if you don't pay, it's an existential risk. You are genuinely just pure randomness away from a massive system breakdown or hack or massive reputational collapse. And you're literally crossing your fingers, right? It's literally a lottery because you have no idea when or how it's going to happen. So if you're in the red, that's the message for me. It's like, this is a window too. And the window after this is existential, right? If we carry on here, the business as we know it won't exist. It might survive, but it's not going to be the business that we know. We're going to have to reinvent it, and not on our own terms. So if we know we're going to have to reinvent it, this is a great opportunity to do so on our own terms. And my estimates as an engineer are that we've got this much time before we're, literally with the bailiffs at the door. And that would be my ultimate, very long-winded answer.
Thank you very much. It's it's actually just really nice as well to hear somebody else speaking with so much passion about a problem that I seem to be living. So yeah, thank you very much.
No, thank you. And I recognize it too. That's where this has come from. So
well, thank you for the question as well, Michael. And one thing I would probably add is you could hire another team, because it's sometimes not necessary the development team's constraint. It might be a constraint outside, so you could hire another team to look after the debt whilst you build the new.
Which would be much better and fun and enjoyable for us. But
not for the new team.
And also, I think that's much more doable in the yellow than in the green, in the red. If you're in the red, generally speaking, the people who've been there for 5 years don't know what's going on. Right? It's like, all the art, but what you do know is that you're crossing your fingers. So bringing a completely external team to do it is unlikely to fly in that respect. Whereas that's a really good strategy if you're in yellow, right? It's already causing you pain, but it's not existential. You're already constrained in your ability to grow and adapt and integrate, but it's not, costing anybody's job. That's a good time to, I think, say, let's bring someone else to maintain our app and let's, build the next thing or go microservices or that sort of thing.
Mm-hmm. Cool, thank you.
Cool. Any other questions?
I was just going to ask a quick one.
Yeah.
Have you actually tried to persuade sort of non-technical directors that they actually need to stop what they're doing, stop everything, throw everything away, or either bring another team in or just reinvest? Otherwise, they're going to lose it all. How do you convince them that this is the right thing to do?
I would say with difficulty and with time. My approach to driving organizational change is two things. One is to depersonalize it. So the kind of metrics that I mentioned mean that it's not because I don't like my work as a dev, or because, it's not sort of, and to get, this is why I'm saying that it's a really good tool to then go, hey, finance director or CFO, could you help me quantify the impact of this on the business, for example? Or, HR or whatever. With churn, for example, how much is it costing us to recruit and to retain talent, etc.? The other element for me is when you're in the red, the pain points are for everyone, right? Everyone is suffering. The person in that bike behind your square wheels is saying, or the person saying, I just want a new window. So finding the allies and building up. I mean, if you're lucky, you'll have sometimes you get some senior manager who gets it and the blockage is kind of more in the middle. But doing presentations, for example, it's like, I want to talk about technical debt. It's like, nobody expects what I'm about to tell you. And, what happens after that? But it might also be much more indirect. It might be that, you, depending on the size of your organization, you get allies, you convince your team, and then someone else introduces you to someone else higher up the chain. And eventually, by the time you get to the decision makers at that scale, it's not you making the case. It's, 5 managers who see their own roadmap blocked. And that's the last thing I think I'd say about that. If you're in an organization where that is an uphill climb, I think the most important tool for you is other teams' roadmaps. If you can map your technical debt to their roadmaps, to their pain points, and you say, this is one scenario, this is what your roadmap looks like in this scenario, then it's their bonuses, their assessments, their team, their pain. So if you're able to do that for enough bits of the organization, then I think by the time you get to the top, it's easy. But as I say, sometimes you're lucky. Sometimes it's the top that says, okay, I get it. I just don't know how. And I'm going to have to convince my board, for example. That's happened to me, where the board is saying, wait a second, we want our money right now. We're not investing for the long term. We want to sell you quickly. So, it's not always possible. And I think that's, the other reality for me. That's one of the decisions that we make in our very privileged careers, right? If you come to the conclusion that you're in red, you're about to go existential, and the company is not going to change, that's not a terrible time to look for alternative positions, right? Because that's where I came from. I kind of said, like, there's no point in me being in this role in one of the companies I work with unless we take this big leap, because I'm just going to watch it crash and burn. And that helps set expectations for both of us.
Yeah, this is literally an academic interest for me. I suppose the other route is you start updating your CV.
Yeah, that's your plan. And I think that is, that's one of the advantages that we have in this process, that, every company is becoming a software company, and we are both the kind of enabler and the weak link in the chain increasingly. And there is a huge sort of labor crisis, which means that, genuinely just go, I'm leaving. So we have more political voice, I think, at the moment to drive that kind of change than almost anybody else in the business, if we are in the right place. It's harder when it's the engineering team that doesn't see eye to eye on that, right? If you have somebody invested in the legacy code who is the, engineering lead or manager, etc., that's the blockage that is much riskier, right? Because that's much harder to pull. But if you're able to kind of, if the engineering team was on one page on that one, and you can speak it in business, then I think if it's not going to change when you put it to them, then it's not going to change. And that's a company that's likely not heading in a good direction regardless.
Yeah, that's what I thought.